Hello guys, welcome to the first video in the series of lectures of the advanced compendium of limits. In this we are going to solve a problem that was asked in CMI 2022. So, and then we have to with this statement we have to say whether the following statements are true or false. So let's talk about it. So statement 25 says f of 1, so that will be f of 1, f1x would be x to the power x. Okay, then we have to find limit x tends to 0 f of 1, so the limit x tends to 0 plus f1x. This is actually equals to limit x tends to 0 plus x to the power x. Okay, now this is 0 to the power 0, so we can also write this as limit x tends to 0 e to the power x ln x, and we can find limit of numerator the power, that is, because it is a continuous function, so we can also write this as e to the power limit x tends to 0, and we can write ln x as x upon 1 by ln x. Okay, and now this has become 0 into infinity, and this has become 0 upon 0. I'm writing ln x as 1 upon 1 upon x, so this solves out to be e to the power, using L'Hospital rule, this we can write as 1 upon 1 by x. So let me write it more kind of precise. So this is e ki power x, and at x equals to 0, this is e ki power 0, that is 1. So statement 25 is true statement at x tends to 0 plus f of 1 x tends to 1. Now let's talk about statement 2. So statement 2 is f of 2x. So statement 2 is S25 is 26 is actually limit x tends to 0 plus f of 2x equals to limit x tends to 0 plus x to the power x. Okay, we can also write this as limit x tends to 0 plus x to the power x. Okay, now this at 0 plus this goes to 1, so this is actually 0 to the power 1, that is 0. Okay, that is 0. So you can see statement second is false. Let's talk about statement 27. In 27 we have to find this function, this thing, which is integral of f of 3x from 0 to 1 dx, that is actually equals to integral of 0 to 1, and this is x to the power x to the power x to the power x. We can see that since x belongs to 0 to 1, okay, then x to the power, then just basic idea about, then this thing will always lie from 0 to 1. Okay, if this is kind of this here. Okay, so and then integral of this thing, I'm just using integral here, so integral of 0 dx is greater than integral of x to the power x to the power x to the power x dx is less than integral of 1 into dx from 0 to 1, from 0 to 1. So this thing is actually less than 1. Okay, so this thing is actually less than 1, so statement 27 is also incorrect. Now let's talk about statement 28. For that I need some space, so I'm gonna rub something there. So integral of f of 3x from 0 to 1 is always less than 1, so statement 27 is also incorrect. Now let's talk about statement 28. So for that we have to find derivative of 123, f of 123 at x equals to 1. Okay, so I'm just gonna write a general form, so that is y of n plus 1 equals to x to the power yn. Okay, that's that. Let me write it here. Y of n plus 1 equals to x to the power yn. Okay, so ln y of n plus 1 equals to yn ln x. Okay, now 1 upon y n plus 1 into dy upon dx equals to yn, and derivative of ln x is 1 by x, plus of taking ln x constant, derivative of y of n is, that is dy dx of y of n. I'm just going to write it as f dash of f dash n of x, and I'm going to replace yn by f n x. Okay, now dy by dx is f n x into 1 upon x plus of f dash n x into ln x multiplied with this f of n plus 1 into x. Okay, now at x equals to 1, this will become f of nx. So this will become 1, and this, so this becomes 1, and here ln 1 is 0, so this becomes 0. Okay, and this fn plus 1x equals to 1, so this ultimately becomes 1. So this statement is also true. So only statement 25 and 28 are true. This is beautiful question that was asked in CMI. So that's all. Like, share and subscribe. Thank you.